Hi fellas, this is Chemaddcts again to the solution. Welcome back to another video tutorial. Well fellas, now we're gonna solve the second now we're gonna solve the third now we're gonna solve the third part of this question, okay? So if you fellas have missed the previous session, previous episode, whatever we call, so don't worry, I will put the link to previous I will provide the whole solution of this question paper at the end of this tutorial, okay? So don't worry, be happy, okay? Ha ha ha. So by the way, happy Thanksgiving Day, okay? And we are so close to Christmas, okay? Haha. You might enjoy this time, really cold. Well, by the way, at first, let us read this question, okay? The lattice energies of sodium fluoride and magnesium fluoride are shown in the table below. Explain in terms of sizes and charges in the ions above. In the sorry. Explain in terms of the sizes and charges of the ions involved why the lattice energy of magnesium fluoride is more negative than that of magnesium fluoride. Okay? So let us mark the key points of this question. So in this question, what they have asked us to find is to explain why why the lattice energy of magnesium fluoride is more negative than that of sodium fluoride. So they have also asked us to explain. They have also asked us to explain in terms of sizes and charges of the ions. Okay, so the question is pretty straightforward. So in here, most of the students get confused about this question, since this question is really similar to another type of question they asked. Here they have given two different compounds, okay, and they have given directly the lattice energy of these two different compounds, okay. So here they have given the lattice energy of two different compounds, and sometimes they give the experimental data and calculated data of each compound. So they asked how they have similar uh, values of experimental value and calculated value, and they have different experimental value and calculated value, and those are different, okay, from this question. Here they have straightforwardly asked us to find this thing. They have also given pretty straight that they have given the lattice energy over here. So we can be assured that we need to explain this thing in terms of sizes and charges. Okay. So we don't need to involve covalent character. Most of the students are really crazy about covalent character. They always love covalent character. Whenever they see this type of question, they always explain in terms of covalent character. That's really wrong. Okay. So it's really wrong. So here we need to explain this in terms of sizes and charges. Okay. So before answering this question, let us write some of the important things. So the first thing for this is, don't explain in terms of covalent character, not covalent, covalent. Okay, since there is no experimental value and calculated value, so since there is no experimental data and calculated data, so we don't bother about explaining it into covalent character. We don't bother about covalent character. It is straightforward, okay. there is another point. If you have noticed that here the cations are different. Okay, so here cations are different. Here is another point. The question has asked in terms of sizes and charge. Okay, so we will compare size and charge. Then, since there is no calculated and experimental data given. Okay, here we have find out one single, that is energy, and in some question they also provide calculated and experimental data for each of the compound. This will have calculated data, and this will have this particular compound will have calculated data as well as experimental data, and this particular compound will also have experimental data and calculated data both. These both things will exist in here, somewhere here. So since they haven't provided these things, so we won't talk about covalent character, as simple as that. Okay, so so here is another thing. If they want us to explain in terms of covalent character, they will provide experimental and calculated data for lattice energy, and we need to explain why the values are similar or different. Here they didn't ask us to compare the experimental data and calculated data, so we won't bother about covalent character. So I hope that I have made the concept of covalent character clear. Okay, so now on, you fellows, you won't make the same mistake that other students usually make. Okay, so that is why we need to explain in terms of the sizes and charges of ions, not the covalent character. So, okay, now let us write the answer from this question. Here there are two cations. Okay, so the cations that are present here is Na plus and Mg2 plus. Okay, so here um, since this is along the period, I hope let me see, along the period 1, 2, 3, along the period 3. If you have remembered, this is the along the period 3. Okay, so if we go across the period 3, the if we go across the period 3, okay, the size of ion decreases. Okay, size of ions decreases if we go across the period 3. Okay, so size of ions decreases and charge also increases. Charge increases. So as we can see that as we go across the period 3, this is in period 3. Okay, this is in period 3. So as we go across the period 3, size of ions decreases and charge of ions increases. Okay, so the magnesium ion will be smaller than sodium ion. Okay, and as we can see that here the charge of magnesium ion is greater than the charge of sodium ion. Okay, so that's makes the difference. So in here the anions, here the negative ions are same. In this case this is fluoride, this is also fluoride. So the only difference here is the magnesium and sodium ion. Okay? So we need to just write like this. Since magnesium Mg2 plus ion is smaller and has greater uh, magnesium 2 plus ion is smaller and has greater charge, or you can say that greater charge density. Okay. So magnesium Mg2 plus can attract more strongly fluoride than sodium ion. That's it. Here the total mark for this question is 3 marks. So for 1 mark we need to, so for 3 marks there should be 3 points for this question. So the first point is magnesium ion is smaller and has greater charge. Okay, smaller, magnesium ion is smaller. Then so magnesium ion can attract more strongly fluoride ion than sodium ion. So for 3 points we need to mention 3 points. For 3 marks we need to mention 3 points. So these are the points. Magnesium ion is magnesium ion is smaller and has greater charge. So magnesium ion can attract more strongly fluoride ion than sodium. Okay. Well, that's the answer to this question. So fellas, I hope that uh, I can make I have made these points clear to you fellas. So I hope that you fellas now can answer this type of question, since this question repeats most of the time during the exam. So now you might find it easy to answer this type of question. So the answer of this question is Mg2 plus ion is smaller and has a greater charge. So Mg2 plus ion can attract more strongly fluoride ion than sodium ion. Okay. So or the other way around, you may answer this question as magnesium 2 plus ion has greater charge density than sodium ion. So for this you will achieve 2 marks, and for the other 1 mark you need to say that magnesium ion can attract more strongly fluoride ion than sodium ion. That's it. That's the answer to this question. Okay. So well fellas, I don't want to make this video longer. So if you have any question regarding this topic, regarding this solution, was this solution helpful to you or not, how much how much of this has helped you in your study, since your exam is pretty close, exam is knocking at the door. So I hope that my solution have at least help you for your exam, help you preparing for your exam. Okay. So that's it for now. I don't want to make this video longer. Okay, so don't mind. So fellas, signing out for today. So see you in the next video. What to say, best of luck for your exam. Stay awesome, stay cool, and as always, peace with chemistry.